Hello, this is Dr. Lori. Welcome back as we start discussing the kinds of research questions that we can ask along with the new parametric tests that we've just introduced. So as a quick review, I wanted to go over the research process that we've talked about in the past. Specifically, we start off by asking a question, and then we think about this designing the study, the different kinds of study designs that we might use, and then about the variables and collecting that data. Once we have the data, then we would talk about analyzing the data and then what we do with it in terms of interpreting or sharing it. Specifically, a lot of what we're going to be talking about today has to do with asking specific questions that have an impact on what statistical tests we choose in order to analyze the data. And when I think about this analyze the data section, I specifically think about three different layers of analyzing the data. Typically, the first thing that we do when we get data is we want to look at it. And that's what this is in terms of the DS or descriptive statistics. So describing it, what we talked about above here in terms of creating graphs, these summary statistics, mean and standard deviation for each scale variable, and in percent, median and interquartile range, that sort of thing. And so we're just simply describing one variable at a time. DS is the first layer. Sometimes we're trying to clean it or identify errors by doing these descriptive statistics. And also, it's a way of summarizing a vast amount of data into a smaller, more manageable amount of information that people can use to make decisions. After we've done that descriptive statistics layer, then we move on most of the time to inferential statistics, or what I've summarized here as IS. And specifically, we often typically start with what's the bivariate, or two variables at a time. Since we have one outcome variable, then the second variable is either the exposure or the predictor or the independent variable. And so we're looking at this relationship between these two variables. Now, keep in mind that just because we're talking about bivariate analysis, we're not automatically implying causation. Sometimes the words we use, exposure, outcome, or even exposure, disease, predictor, outcome, independent, dependent variable, sometimes those relationships imply causation because of the way we typically use those words in the English language. But just because we're looking at a bivariate relationship does not automatically mean that there is a causal relationship happening there. Maybe that those two things are just happening together at the same time. Once we've looked at things in this bivariate way, then we move on to the multivariable inferential statistics. And this is where we still have one outcome variable, but maybe we have two or three or even more predictor variables all at the same time. And often what we're trying to do is correct for confounders, or we're trying to build a model that describes more than just that one thing. Now, keep in mind that this M, depending on whether you're an epidemiologist or a biostatistician, people will use the word multivariable or multivariate, and often they're meaning the exact same thing. In this statistical test, we are only ever talking about one outcome at a time, and it is possible to model things to create these analyses where we're looking at two or more outcome variables simultaneously, but we are not going to go there where we don't have that much time to be able to talk about those things. So analyzing data kind of goes through these three processes: describing it, then looking at pairs of relationships, and then adding in those extra variables to see how that impacts the bivariate relationships. When we're thinking about observational cohorts specifically, because often now we're adding in that idea of having scale variables as our outcome, we can answer several different kinds of questions. First of all, we can look at a particular variable and say, has there been a change over time? Have we had that pre and post difference? Did they start at a certain point with their cholesterol or their BMI, and then after some kind of time has gone by or an intervention has taken place, is that measurement now different? The other kind of question that we can answer is, do we have this is a variable the same for two or more groups? We can look at two groups, compare them to each other, or we can have three or more. And so this is another common question that we would want to be answering. And then a third one really is looking at just the correlation between variables, looking at that relationship. Is there a correlation between a specific variable and maybe another variable? So that's another kind of a question that we can ask that isn't dependent on whether there are groups that we're comparing to. So these kinds of questions lend themselves to different kinds of inferential statistics, specifically the bivariate kind. And so if all we're asking is what's the average of a variable, then our answer is descriptive statistics. But as soon as we're asking these kinds of questions, a change in a variable from one time to the next, so we're comparing two things, but it's because time has passed in between, then that would lend itself to a specific kind of inferential bivariate statistic. If we're looking at whether a particular variable is the same for two different groups, that's a different statistical analysis, a statistical test. And if we're looking at correlation between continuous variables, then again, that bivariate inferential statistical test is going to be a little bit different. So depending on the question, that really helps us to know what kind of statistical test we're after. So join me as we go through those different questions, and we'll think about each one of them one at a time in our future videos.